Okay, so I'm going to treat you like you are a student pilot and you would be a CFI. So, as a CFI, you need to teach somebody who doesn't know anything, like doesn't know how airplane fly. Okay, so let's start. How does airplane fly? Do you know? Are you excited to know?
I'm super excited to learn.
Awesome. Okay, so let's talk about this. This is an airplane. So the airplane goes forward, right? So the force which is acting in the forward motion is called thrust. The propeller rotates and it just pulls the airplane forward. That is called thrust. Okay, so let me draw. I'm sorry I'm bad at drawing, but I'm just going to write this. So thrust is in the forward motion. And when the flight is going in forward, the relative wind is always coming to the opposite path of the motion of the flight. So we have relative wind here. Okay? So what is another force you think, whatever you are in the plane, your passenger, the fuel, everything, what is acting downwards?
The weight of everything.
Exactly, so the weight. Awesome. So we got the thrust is going forward, the weight is the gravity was pulling you down towards the earth. And we have another force working on the plane. The third one is the magical force, it's called the lift, which is upward. What is lift now? So in order to tell you lift, I would like to bring in two beautiful scientists. One is the Mr. Bernoulli. Do you know anything about Bernoulli's theorem?
I don't.
You don't? Okay, that's fine. I'll tell you. So Bernoulli was a scientist and he came up with like a venturi tube. So what he said, when the fluid goes inside the venturi, when it speeds up because the narrow opening, the narrow size in the between, when it speeds up, when the velocity increase, the pressure decrease. So now if you look at the wing of the airplane from the side, it does look kind of the shape at the side of the venturi. So it will look like, if I draw a wing like this, so it is kind of a venturi, right? So what happens when the wing goes forward, the air speeds up here, so here the velocity increases, what happens to the pressure?
It decreases.
Okay, so it decreases. Awesome. So at the bottom of the wing, if you see, it's not curved like that. It's kind of not that much of curve. So there is nothing happening for the pressure here. So velocity is still same and the pressure is more than above. So things like to equalize. High pressure wants to come up and equalize to the low pressure. So what happened, we have this low pressure on the top but high pressure at the bottom. So the airplane, that pressure will actually push the airplane up.
Okay.
So that is the one biggest way we get our lift. The second way we get our lift, I would like to bring the magical, another famous scientist called Newton. Do you remember any of the Newton's law?
Don't quiz me on
No.
something like
Okay.
that. I don't remember.
You don't remember. That's fine. You don't have to be scientist. But there are many. First law, second law. We worried about the third law, which is the easiest law. Every action has opposite reaction. So let me tell you how. I'm just going to take this thing out. So what happens is when you put your wing at an angle, when you put the wing at an angle, when you have this relative wing striking at an angle, that wing will get pushed down, right? This get deflected. So when it get deflected, every action has opposite reaction. It pushes the wings on the top. So that will also, so when you have wing, when you basically pull up the nose, when you have wing touching here, it will actually lifts up the airplane. So those two theorem or those two laws creates our magical force lift. Now we have something called drag. Do you have any idea what drag would be?
The opposite of thrust.
Awesome. That's excellent. So I would like to think about a guy on the motorcycle. If the guy is on the motorcycle riding, and the more speed, more faster he goes, what's going to happen? What the air is going to do?
It's going to blow him off the motorcycle.
Awesome, the resistance. So the airplane is the same thing, you know. I know the wings are the coolest part, they create the lift, but you look at that, the landing gear, this antennas and stuff like that. When you drag them in the air, the faster you go, more and more you get the drag. Okay? So that drag is the one kind of drag that is called our parasitic drag. Okay? So the faster you go, you get more drag. Another drag we have something called is induced drag. So we have two different kind of drag. Induced drag I like to think about like a hand. And when you're driving, you put a hand on outside the window and from the car. So when you put the hand like straight and you're going, the hand will go which way?
It would go back.
Back. But now I put the hand in the angle, what will happen to my hand?
It would go up.
Up and back. Awesome. So when you're trying to create a lift, up and drag. So when you're trying to create a lift, in that process, you also get some drag. That is called induced drag. Okay. So we have thrust, lift, weight, and drag. I would like to talk this more detail about the drag, the parasitic and induced drag. As we remember the guy on the motorcycle, the faster we go, we have more parasitic drag, right? So I'll write here is the speed, kind of try to write like a graph, and we have drag here. Okay, so the faster we go, the parasitic drag will increase. This is your parasitic drag, right? What happened to induced drag? Induced drag is also, the Carrie asked me, this question is, people might ask, why do we have more induced drag at the low airspeed? Because when we have low airspeed, we need more and more angle of attack, which I'm going to talk later what angle of attack is. But when we have low, we need the newtons. Remember, when we have lesser speed, the pressure, if we need to pull back a little bit more to have that Newton third law working. So when we pull back more, what happens, the lift is actually to the up of the airplane, but when you pull back, the lift is actually working behind. So the lift is actually becoming more like a drag when you have nose-up attitude. Do you agree? So that's why we have more induced drag at low speed. So this is your induced drag. So what, as a pilot and as a manufacturer, we know what manufacturer will suggest a speed where we have minimum of the induced drag and minimum of the parasitic drag, the lowest. So we need the 1 point, which is our best gliding speed. So if you lose the engine and you maintain that speed, you will glide all the way to the ground. And that will be like our total drag curve. This is the point where you have the best glide. What is best glide? The ratio where the induced and parasitic is the least and lift is more. Okay? So that was our basic aerodynamic. After we do that, I would like to talk to you about some definition. I spoke about what angle of attack is. So I draw this wing again. Sorry, my marker is not working. I draw this wing again, which I'm not good at drawing. So the front of the wing, it's called leading edge. And the end of the wing is called trailing edge. Some fancy terms you just need to remember, but it's nothing so difficult, okay? So if I join this front, the leading edge and the trailing edge, this line, this is your chord line. And just for this drawing purpose, I would like to extend it a little bit. Okay. So what happened, remember when the airplane is moving forward, we have relative wing coming towards us. So when the angle between relative wing and your chord line is called your angle of attack. Does that make sense?
Yes.
Okay, so remember I spoke about Newton's law, and then when we have a little bit, and we're going to push this airplane fast. We have, and also the Bernoulli is moving the pressure difference because we have smoother air, and we have nice and good lift. But this is your angle of attack. What happens if I just pull back so much, hypothetically maybe? What happened? Do you think the air will pass on this? Here it's going, but it won't.
Yeah,
It will
probably not.
Yeah, it's going
It's
to
not
be.
that sticky.
Yes, it's not going to stick. So there will be no pressure difference, right? So there is no pressure difference. We're not going to produce enough lift. We'll still make little lift, but not enough lift to hold our weight. So the lift should be able to be at least so much where you can support our weight. So if you don't make enough lift, which doesn't support the weight, we're going to stall. So every airplane has an angle of critical angle of attack, COA, critical angle of attack. If you exceed that, you're going to stall. So airplane will stall only if you exceed critical angle of attack. So when you are at the low speed, you need more angle of attack, right?
Mm-hmm.
So when you when you exceed that angle of attack, it's not the airspeed, it's the angle of attack. You will stall. You can stall. So sometimes the examiner would ask, just as a CFI thing, I'm telling you that what happens. So if you do anything abrupt motion like maneuvers, and so suddenly you're going down, right? So if you're going down, where the relative wind is coming?
From below.
From here, right? From this angle, right? And suddenly you pull back. Even you have a lot of airspeed, this is how you got accelerated stall. If you abruptly pull back, you're going to stop because of the momentum, the relative wind is still coming from here, and you pull back, you exceed the angle of attack. For our Cessna, it's like 17 to 18 degrees. But don't quote me on that. You can find it in a POH for every airplane, and you're going to stall. So in order to come out of the stall, what do you need to do then?
You need to pitch back down
All
toward
you
the
have to
relative
just
wind.
come down to 17 degrees. 17 and a half, you probably stall. 17, as soon as you have that air coming, you produce lift. So when you have stall, you just have to make a pitch down, and you will recover. Then we have an interesting thing is what is spin. Do you have any idea what spin is?
No idea.
Okay, so basically stall is like you're not producing lift, you're going down. Spin is something when one wing will stall more than another, which we'll call rotation, and you go like right into the ground. Okay, that is called spin. So in spin, like are you making one wing is making enough lift, another wing is also making some lift, but one wing is making more lift than others, but they both are stalled in the spin, and you just go zoop like in the stall. So you don't want to do that, especially when you're close to ground. And I follow a little I follow this little mnemonic to recover from the spin called pair. So what pair is? First, I would like you to just write the note because examiner asked me how do you recover from the spin. So you just write P power idle, neutral aileron. If they ask, otherwise you don't want to go to spin before we talk about the elevator controls.
Okay.
So power idle, neutral aileron, opposite rudder, and elevator briskly forward to come out of the spin. Okay, so excellent. That is our. Now, I would like to talk about the controls of the airplane. So if you look at our airplane, we can make yaw left and right. That is done by the rudders in your cockpit, like the pedals. When you press that pedal, we have this tail which have a horizontal stabilizer. It has something called rudder. So when you press left rudder, what happens is the left rudder deflects to the left, and it creates a drag here which pushes the tail to the right and nose to the left. Same with the right. When you press the right rudder, it creates a drag. It's deflected to the right. The tail goes to the left and nose goes to the right. Something we make up and down, the pitch. So how the pitch happens, we have something at the elevator. So what happens, we have these two elevators at the back. We have yoke. When you pull back on the yoke, the elevator goes up, which creates kind of a negative, like a drag here, which pushes the elevator back down, the tail of the up and down, which keeps the nose up. And when you push the elevator, the yoke in front, the elevator actually deflects down. That will create like a more curvature here. That will create a lift. So your tail will go up and nose will go down. Okay? Does that make sense?
Yes.
So, and then another thing, we have something called roll. So to turn, we use our something called on the end of the aileron, the wings, we have these two aileron controls. So if one goes up, one goes down, one goes up, one goes down. So if you want to turn to the right, you actually use rudder and aileron both, but I'll come back to it. But you turn the aileron to the, when you turn your yoke to the right, the right aileron goes up. That will create drag here. That will cause the wing to drop, and also the left aileron goes down. That will create more curvature of the wing, and they will probably ask what is the curvature of the. It's basically the distance, like how big is your wing is. So it will create a curvature of the wing. It will create more lift here, and you will roll. Same thing when you do the left. The left will go up, right will go down. More lift generated here, and go to the left. And you probably need some little bit rudder to come out of, because what happens is, remember, when we create lift, we also create drag. So what happens is when you're supposed trying to turn right, the right aileron goes. This is question on your commercial return. The right aileron goes up, left aileron comes down. So when it's creating lift, it also creates some drag, and you will have like this movement. So when you're trying to make a turn right, it will momentarily yaw to the left because of the downgoing aileron. So you need some of the right rudder as well.
Okay.
Does it make sense?
Yeah.
So that is your question on your test. So we got that done. So let's talk about stability. Okay, so I would like to talk stability is, we have something called static stability and dynamic stability. We use this our aeroplane, that training aeroplane, they're very stable. The first tendency to come to the original position is called static stability. So when you go deflect down, the initial tendency, it will try to come back to your original position, no matter down, left, right, whatever happens with the turbulence, it will try to come back. It's a static stability. So the way how I explain is, I will have like a little ball in a ball in a bowl. So if you, what happens, I don't think you can see in my video, but let me write like big one. So we have a big little ball in a bowl, and if I deflect the ball to any position, what will happen to the ball?
It'll want to roll back.
Roll back, right? Initially. So initially it want to come back to its original position. That is called your positive static stability. Then we have something called negative static stability. So I just put the ball upside down, put a ball here, and if I deflect the ball to a new position here, what do you think the ball will do now? Would it go back? Or
No, it's going to go it's
further,
gonna keep
right?
rolling.
So this is called negative. When you actually move the aircraft from one position to the new position, it will just go towards that position, which is very bad. We don't want it for a stable aeroplane. So that is called negative static. And there's another, if I draw like a straight line, I have a ball here and I deflect it to the new position, it's just going to stay right there, right?
Yep.
It's called neutral. So this is called your stability. In order to be a plane to be dynamically stable, we have to have a positive stable. This is kind of confusing, but think about that. The first tendency to come back to its original position is called static stability. Dynamic stability, like what the airplane do over the period of the time. So if I deflect the plane down, it want to come back, that is static stability. Go up, it will want to come back, that is static stable. So dynamic stable is like when it come back, it will then go back, go upward, go back, that is dynamic. So over the period of time, what it's doing. So I will try to show what 3 types of stability. I'll get rid of negative and neutral because the first intensity, it has to be positive. So what happened is, suppose this is my original plane, this is the original position of the airplane. I deflect to the new position, it will come down, back, that is static stable, go down, go back up a little bit, go down, go back up, go down, and like that, and then come back to the original position. This is called dynamic stability and positive stability. So what happens is oscillate, it goes up, want to come down because it's static stable, then keep going down, then come up a little bit, now slowly, is going to come back to the original position. That's called positive dynamic stability. Okay, so the second one I have is the negative dynamic stability. Well, I'll draw. So first we start here. It will go up. Because it's positive static, it will go down. But we'll go down more, go up more, go down more, go up more, go down more, go up more, go down more, go up more. This is like going way bigger acceleration. So it will start with a little oscillation, but then eventually it's going to make bigger oscillation. That's called negative stability, negative dynamic. Are you understanding?
Mm-hmm.
So then we have a neutral dynamic. Is like it start from here. The initial positive static stability, it will come down, but it like this. It will keep doing the same oscillation hypothetically, unless something stops. So over the period of time, just keep doing like that until forever, you know, hypothetically. That's called your neutral dynamic. So I would say how our aeroplane is stable. So I would like to talk about that now. Where do you think the heaviest equipment, what is the heaviest equipment or in the plane?
The engine.
Like part, the engine. And where is it? It's at the front or the
It's
back?
at the front.
Exactly. So we have nose heavy airplane. Okay? So think about that. Look at my wings. They're a little front, okay? So my engine is here, is the heaviest thing. Okay? So if I don't do anything, probably the wings are making lift, but it's just going to fly like this. To make it stable, we have something called this horizontal stabilizer, which is basically an upside down wing. Why? Because the wings are making lift up, right? But the engine is still heavy. To compensate that, here is the lift on the wing. The elevator is actually making a negative lift to keep the tail down.
Okay.
So we can have the engine going up. Do you understand?
Yeah.
So the elevator is like upside down wing. So what happens now, how does it make it stable? What happens is we are flying in the cruise flight, the gust comes or something happens, the turbulence, and we go nose down. And when you go nose down, what is going to happen to your airspeed?
Going to increase.
Exactly. So when we have more airspeed going, we have more airflow coming on our horizontal stabilizer. So when you have more air coming on your horizontal stabilizer, it's going to make more downward lift. And when this is important, it will create more downward lift, so the tail will go down and the nose will go up. And you'll come back to the original position. Now what happens when the gust will throw the airplane a little bit up? So it starts a little bit climbing. What happens to your airspeed?
It it gets lower.
It goes lower. So exactly. So when you have lower airspeed, you have less airflow going on your horizontal stabilizer. So it will reduce the bottom lift. When it has less of the bottom lift, it's going to make the lift, because it's going down, right? So it's going to make less of the downgoing force. So that's going to push the tail back again, and the nose of the airplane is going to bring us the airplane in the same position and start flying again. Does that make sense?
Yeah.
So this is this one, and this is how it makes our airplane stable. The second one is I would like to talk about is Dihedral. Welcome, Dylan, to Dihedral. You teach me Dihedral.
Oh no.
No, come on.
No, you're the CFI.
No, really. You're doing good at it. Then you probably remember. Come on.
I remember the part that I have.
Okay, so this is what I showed to my examiner, and he was very happy.
Yes.
And he made 2-3 points. So I'm going to give you one basic example. Probably it's not the best, but I will also give you the second example if you want to more detail. The dihedral is the wings are actually not straight, because if they are straight, the lift is going up like this. But if you look at our Cessna, I don't think you can look very clearly. It's not the best example, but the wings are actually fixed at an angle. Maybe this is a little exertion, but so what happened, the lift is actually going in this way and this way at an angle this side. So wings are like this, so the lift is actually making like this. So what happened is, let me make an airplane. So the dihedral means the wings are like this. So this one is making lift here and this one is making lift here. So what happened is when the gust comes, the one wing will drop, one will go up. So this one is making horizontal lift more and this one is making here. So this is creating more lift. So that will push the aeroplane back in the original position. This is the simplest I would teach to the student, but if the examiner wants to ask some more, then I will show, because it has a dihedral and the wing is dropped down, one wing dropped down, what happened is this one is, the way it's going, I'll show this. If the wing is dropped down, the way it's going, this one is making lift this way, and this one is, that will push the airplane go sideways, but when it pushes sideways, because the flight path is an angle, now we have relative winds coming from this angle. So the more relative winds is hitting this wing than this wing, because the fuselage is in between. So look at this. So when you have more relative wind coming here, that will bring your lift back more and it will bring the airplane back. So this is like slipping and that will bring back. So that is your dihedral, so we need that for our stability to bring our airplane back. Another stability is around the vertical axis is the wing, the airplane is like a weather-worn thing, so it will move your nose to the wing. To correct it, you see we have the big tail, it's so huge, the vertical stabilizer. So if you have wind coming from here, if you have wind coming from here, the nose will become into the wind, but now with the horizontal, if you look at the horizontal stabilizer, it is more force towards the wing that will, no, I'm sorry. So if it goes here, now the wing actually, so wing will push from here and will be back. Does it make sense?
Mm-hmm.
So because of the horizontal stabilizer, it will bring the airplane into original position. So that was the stability. Any questions on that?
No.
Okay. So third one, after that I would like to talk about, that's aerodynamics. I spoke about stalls, angle of attack. I don't think anything more. That's it.
That's how airplanes fly.